Good morning. Today we're going to start talking about Chapter 7, which is entitled Radical Expressions and Equations. And we're going to begin, of course, with Section 7.1, which is entitled Radical Expressions. Alright, radicals. What does it mean to be a radical? Well, let's see. If we ask what's the square root of 4, well, of course, we all know what the square root of 4 is. What I want to talk about is some definitions here before we go on. Alright, radicand is a fancy word for the stuff under the radical sign or the root sign. I prefer the word root rather than radical. So I'll use the two interchangeably. And notice when there is no index specified on a root, we assume an index of 2. We'll talk more about that when we talk about higher index roots. So if I ask what's the second root or the square root of 4, well, most of us would write it informally like this. The square root of 4 is, of course, 2. And if I ask you why, I'm going to say because. Now, I believe I've used this before in this course. When the three dotted triangle points down, that is equivalent to the word because in mathematical symbols, right? The square root of 4 is 2 because the number I square to get 4 is 2. In other words, 2 is the number I square to get 4. So really I'm working that squaring operation in reverse when I'm talking about a square root, hence the word root. Well, on we go. The square root of 9 is, of course, 3. Why? Because the number I square to get 9 is 3. In other words, 3 squared is 9, so the square root of 9 is 3. And again, the square root of 100 is 10 because 10 is the number I square to get 100. Alright, I want to make a little bit of a note here, but this comes into play later on in the homework assignment. Note, the square root of 4 is 2. Well, not negative 2. I think you'll agree, if I can square negative 2, I also get a 4, so why don't we call the square root of 4 negative 2? Well, we do this by arbitrary agreement. Right? We'll agree that, in other words, in simple terms, square roots are always positive. Right? We eliminate that negative root from consideration for square roots. The square root of x, we agree that the square root of x is the positive square root of x. Right? Some books call this the principal, meaning positive square root of x. So, in other words, the square root of x is the positive entity or value, I'll call it, whose square or second power is x. Alright? Please note, the square root of 0 is 0. Technically, by definition, 0 is neither positive nor negative, so we'll make that a special case. The square root of 0 is 0, and I suppose you already knew that. Let's look at some other, perhaps more interesting examples. If I ask for the negative of the square root of 225, well, please notice this negative sign is like a negative 1 multiplier outside the root operation. So negative square root of 225, well, the square root of 225 is, of course, positive 15, so my answer return here would be negative 15. Please contrast with this problem. If I ask what's the square root of minus 64, well, I'm going to conjecture that there is no number I can square to get a negative number. If I put in here a positive quantity, I will not get negative 64. If I put in here a negative quantity, I will also not get negative 64 when I square it. So the square root of minus 64, our text takes the language, it's not a real number. Alright, so the long and short of it is, again, informally, you can't take the square root of negative values. Another example. The square root of 49/4. Alright, don't panic, it's a fraction. Yeah, your calculator will always give you a decimal approximation for any root. I think we can do better here. The square root of 49/4. Well, hopefully you can identify both the numerator and denominator of that radicand expression as perfect squares. Well, I can take the square root of perfect squares very easily then. The square root of 49/4 is 7/2, positive 7/2. And again, because 7/2 is the value I square to get 49/4. So if 7/2 squared is 49/4, then the square root of 49/4 is 7/2. Negative square root of 1, well, we all know what the square root of 1 is. The square root of 1 is 1, so negative square root of 1 is negative 1. And of course, the square root of negative 1, notice the difference, that will be not real. You cannot take a square root of negative values. Alright, let's start talking about some variable expressions. Write a little heading here. Roots of variables, or variable expressions, let me say. Let me ask, what's the square root of x squared? Well, notice, again, when no index is specified, we assume an index of 2. We're looking for the second root of x squared, or the square root of x squared. Most people would answer x, and they'd almost be right. Well, it's x if x is positive. Please note, x is a variable, and hence might be a negative value, and we have agreed that square roots can't be negative. You can't take the square root of a negative value, and square roots themselves can't be negative. Okay? So we've got to preclude that event from happening. So I'll wrap that x in absolute value signs to go along with the convention that square roots are principal roots, hence positive. Square roots must be positive. So the square root of x squared is the absolute value of x, technically, if there is no restriction on x. If x is allowed to be a negative value, we've got to wrap that answer in absolute value symbols. You'll see that absolute value symbol popping up in many of the homework type problems. Try another one. Now, can we simplify this? Well, I think you know where we're headed here. That radicand expression, remember the stuff inside the root sign, fancy name for it, the formal name for it is the radicand, and I'm hoping you can spot this radicand, this trinomial inside, as a perfect square binomial. In other words, it's the square of x plus 1. Alright, let me take a minute. We don't have to be so formal all the time, but I'm going to rewrite this with my explicit index of 2 and the square root of something squared. Well, really the root operation and the squaring operation invert each other. They're inverses of each other. So I can say, let me rewrite this, the square root of x plus 1 squared is really x plus 1, but again, x plus 1 might be negative, might be a negative expression depending on the value of x. So I've got to wrap that response in absolute value symbols to preclude that event. Square roots must always be positive. So my final formal answer is the absolute value of x plus 1. Simplify. The square root of m to the 4th power. Well, the square root of m to the 4th power is m squared. Is it not? Because m squared equals m to the 4th. Right? In other words, m squared is the quantity I square to get m to the fourth. Now notice I didn't wrap this answer in absolute value symbols, and I suppose formally you might do that, but m squared is already positive, so in this case the absolute value symbols are redundant, so I could easily call my answer m squared and be totally correct, because anytime you square a number you get a positive return. Try another one. Let me get a fresh screen here. Simplify the following root expression. The square root of 49 r to the 8th power. Well, think about this. Square root, well, I want some quantity that I square to get 49 r to the 8th. Whatever's inside the parentheses then will be the square root of 49 r to the 8th. Well, 7 squared is 49, is it not? And r to the 4th squared is r to the 8th power. So I can say then the square root of 49 r to the 8th is 7 r to the 4th. Alright, I can put my little because symbol here, because 7r to the 4th squared is indeed 49r to the 8th. So there's my return there. And notice again, I didn't have to put absolute value symbols around it because I know 7 is positive, and any value r to an even exponent will of course be positive. Alright, so we reviewed square roots pretty well. I want to talk about higher index roots now. And by that I mean not just square roots or second roots, but third roots or fourth roots, etc. Again, just to review, this is what I call a root sign or a radical sign. Again, I use the words root and radical somewhat interchangeably. Our book tends to stick with the more formal word radical. Again, the stuff inside the root sign is the radicand, and the number in the crease here of the root sign is of course called our index. Well, not all roots are second roots, not all roots are square roots, as we know. We can have cube roots, fourth roots, any index roots in theory. Let me talk about the nth root of x. This is the value or entity whose nth power equals x. Alright, somewhat similar to the square root case, but we're going to extend that to higher order indices. For example, the cube root of 8, or the third root of 8, is what? Well, I want the number that I raise to the third power to get 8, and of course that's 2. Right? The cube root of 8 is 2, or the third root of 8 is 2, because 2 to the third power equals 8. Contrast that with this statement. What's the third root of minus 8? Well, notice the index here is odd. Well, that means it's okay to have third roots or odd index roots that are negative. I claim the cube root of 8 is minus 2. You might ask why, and I would respond that minus 2 to the third power is indeed negative 8. Well, because you've got an odd number of factors here, minus 2 times minus 2 times minus 2, you can indeed get a negative return when you've got an odd string of negative factors. Okay? So the cube root of 8 is 2, the cube root of negative 8 is negative 2, so it's okay to take odd index roots of negatives. You can't take even index roots of negatives, but you can take odd index roots of negatives, and indeed it's also okay for odd index roots to be negative. Let me write that down also. Okay, for odd index roots to be negative or have negative responses, right? Alright, what's the cube root, or the third root, of minus 27? Well, of course, you're going to say the third root of minus 27 is negative 3. Why? Because negative 3 is the number I raise to the third power to get negative 27. Okay. What's the third root of positive 125? Well, the third root of 125 is 5. And again, because 5 to the third power is 125. Hence, 5 is the third root of 125. Let's mix this up with some variable type expressions. Higher order indexes of negative radicands. Simplify the following root expression. Well, what's the third root or cube root of minus 64 x cubed? Well, negative 64, I think I recognize 4 as the cube root of 64, so hence negative 4 would be the cube root of negative 64. I claim the third root of minus 64 is going to be negative 4x, and I don't need the absolute value symbols again because my index is odd here. Alright, the cube root of minus 64x cubed is minus 4x, and again the reason why is because when I raise minus 4x to the third power, I do indeed get minus 64x cubed. Alright, so notice when the index matches the exponent of something inside, they tend to invert or reverse each other and undo those operations to get back what you started with under the root sign. Try again. The cube root of minus 8 a cubed. A cubed, let me rewrite that. A cubed times b to the 6th power. Well, I know what the third root of minus 8 is. That's going to be negative 2. I know what the third root of a cubed is. That's just a, is it not? Now, what's the third root of b to the 6th power? Well, I claim that's b squared. Alright, so the cube root of minus 8 a cubed b to the 6th, I claim, is minus 2ab squared. And why? Remember, you're answering this question, what value, what entity, what expression do I cube to end up with a minus 8a cubed b to the 6th power? Well, of course, that's going to be a minus 2 because minus 2 cubed is minus 8. A because a cubed is a cubed. And b squared, be careful about that b squared, because b squared to the third power is b to the 6th. So final answer, minus 2 ab squared. Anyway. Alright, so we pounded some third roots pretty well. Let's talk about even higher index roots. How about the fourth root of 625? If I ask you to evaluate this expression, that means come up with a value or a number for your final answer. Alright, the fourth root of 625, by definition, that is the number I raise to the 4th power to get 625. Alright, so if I claim this is my answer, well, whatever I put in here and raise to the 4th power has to be 625, and of course I know that's 5. Alright, check it. Is 5 to the 4th power equals 625? Indeed it is. 5 times 5 is 25. 5 times 25 is 125. And 5 times 125 is 625. So either formally or informally, you can check your answer. The fourth root of 625 is positive 5. Okay? And again, we'll agree that even index roots must be positive. Okay, we call that the principal or positive fourth root of 625. Minus 5 won't cut it here. And again, somewhat informally, you can't take even index roots of negative quantities. Okay? You end up with that not real situation again. I'll give you the simplest example possible, I suppose, is the fourth root of negative 1. Well, if I don't know what this is, basically what I have to identify is some number that I will raise to the fourth power to get negative 1. And there's nothing that you can raise to an even power to get a negative value. So I claim this is not real. Can't take even roots of negative values, right? Alright, so we did a couple of fourth roots. Let's talk about fifth roots. What's the fifth root of minus 32? Now again, it's okay to have odd index roots of negative radicands. You rewrite this. The fifth root of minus 32 is what? Well, I claim it's minus 2. 2 to the fifth power is 32. And we can agree that minus 2 to the fifth power is going to be negative 32. I claim the fifth root of negative 32 is negative 2 because negative 2 to the fifth power, well, again, you've got an odd number of negative factors here, so please talk yourself into the fact that minus 2 times minus 2 times minus 2 times minus 2 times minus 2 is going to be 32 with a big fat negative sign in front of it. Alright? So the fifth root of minus 32 is minus 2. That's my return there. That's a fifth root. We can even go higher. What's the fifth root? Let's try sixth root of 1 over 64. I can evaluate this. Well, 64. Is 64 a sixth power? It is. I believe it's 2 to the sixth power. I claim the sixth root of 1/64 is 1/2. And I'll claim that same rationale as before because 1/2 to the sixth power is 1 over 64. Now, I'm not going to draw a string of 6 factors of 1/2 here. Please note that 1/2 to the sixth power, by our rules for exponents, is 1 to the sixth over 2 to the sixth. 1 to the sixth is 1. 1 to any power is 1. And 2 to the sixth power is 64. 2 times 2 times 2 times 2 times 2 times 2 is 64. So I have verified this statement. Hence, the sixth root of 1/64 is positive 1/2. Alright, fresh screen. Simplify. How about seventh order roots? Well, let me take it easy on us here. What's the seventh root of 10 to the seventh power? Well, you're going to ask yourself, what number do I raise to the seventh power to get my radicand? It's 10 to the seventh. Well, of course, 10 is the number I raise to the seventh power to get 10 to the seventh. So my answer here is going to be 10. So here's a classic example of where you can see the root operation and the power operation standing as inverses of each other. The seventh root kind of cancels out the seventh power, and you end up getting your base back. In other words, the seventh root of 10 to the seventh power is 10. Extend that rationale to variables. What's the fifth root of x to the fifth power? Well, the fifth root of x to the fifth power, of course, would be x. X is the quantity I raise to the fifth power to get my radicand. And notice I don't have to put absolute value symbols on this final answer, so it's okay for odd roots to be negative. So I don't have to restrict my answer to positive x values only, so please be aware of that. Contrast that with this statement if I ask you to simplify the fourth root of x to the fourth power. Well, the fourth root of x to the fourth power, well, you might say it's x, but you'd be at least partially wrong. Again, even index roots must be positive, so if x can be negative, if there's no restrictions on x, we've got to surround that answer in absolute value symbols. Again, by definition, by agreement over the eons of time, we agree that even index roots or radicals must be positive. We call those the principal even roots. Okay? Simplify. The fourth root of 81 times x to the eighth power. Well, what's the fourth root of 81? I believe that's 3. 3 times 3 times 3 times 3 is 81. So I claim the fourth root of 81 is going to be 3. And what's the fourth root of x to the eighth? Well, that's going to be x squared. Again, I claim the fourth root of 81x to the eighth is 3x squared. And again, we could check our answer and claim because 3x squared to the fourth is indeed 81x to the eighth. Check it out. 3 to the fourth is 81, and x squared to the fourth power is indeed x to the eighth. And notice I didn't have to put any absolute value symbols around that answer. 3 is positive, of course, and x squared, of course, is positive. I suppose if you want to be super formal about it, you could say your answer is the absolute value of 3x squared. But again, those absolute value symbols are redundant in this particular problem, so I could easily claim 3x squared as my final answer. Simplify. The square root of 169 p to the fourth power q squared. Now again, when there is no index specified, we assume it's the second root or square root. And notice how I put a little hash mark down there to make clear what is and is not under the root sign. That can sometimes be a problem later in this chapter. Alright, the square root of 169 is of course positive 13. The square root of p to the fourth power is p squared, and no absolute value symbol needed there, but the square root of q squared is q. And again, to preclude the possibility of negative values, I've got to wrap absolute value symbols around that q. If q is unrestricted, I have to put absolute value symbols around q in my answer there. So 13 p squared times the absolute value of q. How about the sixth root of minus 729? Well, I'm thinking I have an answer in mind, but when I notice that my index is even and my radicand is negative, I can automatically write down not real. You can't take the even root of a negative value. How about the third root of minus 512 x to the sixth power? Alright, well, here in my index is odd, and it's okay to take the odd root of a negative value. Well, what's the third root of 512? Well, 512, I believe, involves 8. 8 times 8 times 8 is 512. So I claim the third root, or the cube root of minus 512 is negative 8. And what's the third root of x to the 6th? Be careful about this. What value, what entity do I raise to the third power to get x to the 6th? I claim it's x squared. Again, you can check your answer. I claim the cube root, or third root, of minus 12 x to the 6th is minus 8x squared. Remember, I want to raise something to the third power to get, let me rewrite that, I'm a little cramped here. Because what value do I raise to the third power to get minus 512 x to the 6th? Well, minus 8 cubed is minus 512, and I claim x squared cubed is x to the 6th power. So my final answer here will be negative 8 x squared, and I don't need absolute value symbols because, of course, I've got an odd index root here. One more, we'll call it a day. And what's the third root of minus 343? A to the 6th times b cubed. And I claim that can be simplified. In other words, I want the third root, well, let me worry about the coefficient here. The third root of minus 343 is, let's see, I believe it's negative 7. Yes, 7 times 7 times 7 is 343. So I claim the cube root of minus 343 is going to be negative 7. The third root of a to the 6th is a squared, for reasons we gave above. And the cube root of b cubed, well, the root power and the root function and the power function undo each other, and I get the the third root of b cubed is in fact b. Again, you can check your answer. What quantity do I raise to the third power to get minus 343 a to the 6th b cubed? Well, I claim minus 7 cubed is negative 343. A squared cubed is a to the 6th power. And b cubed is b cubed, is it not? So my final answer for this simplification would be minus 7a squared b. Alright, so we'll call it a day at the 33-minute point for section 7.1, radical expressions.